everybody.
Today I want to talk to you about the star cluster for the fourth session. Let me share a screen. Okay. You see in here, for abundance for sun, X, as I told you already, is represented for hydrogen. And for star, for our sun, we have 0.73 hydrogen. For Y, that we call it helium, we have 0.24. And Z, for other metallicity, we have 0.02 metallicity for all other elements. And you see that in sun, we have much more hydrogen than helium and mostly for other elements. And this is the ratio of other elements into our hydrogen, that is 0.02. In here, you see, if we have more metallicity, we have more or higher opacity. As you can see in here, isochrones for elements that has more metallicity, it is higher. In here, we compare two clusters. For these clusters, we have the same, for example, in T effective and luminosity. And in here, we see that the different helium abundance. If we have different abundance, we have different metallicity, we have different isochrones, as you see in these two pictures, plots. So what means normal? Is the abundance of the sun representative for all stars in our neighborhood? If not, what is the spread? Is the metallicity in the solar neighborhood representative for the whole Milky Way? Is the metallicity depending on the age? Now we want to answer these questions. For the first question, we can say yes. The abundance of the sun representative for all stars in our neighborhood. For example, in here, someone had some estimate for 180 stars within 15 parsecs around the sun. And they saw that, yes, the abundance are somehow for the sun is representative for all neighborhood. And for widespread of iron over hydrogen abundance, we see that in here, in this plot, you can see the iron over hydrogen, and this is for iron ionization. And for sun, the mean is minus 0.09. It is less. Sun is minus 0.1 for logarithmic, that is, it is under abundant. And for here, we can see for the next question that is related to the metallicity. Is the metallicity in the solar neighborhood representative for the whole Milky Way? If we have, we see in this plot that metallicity for open clusters, for example, here is our sun, and here is our neighborhood. If in our, for example, central galaxy, we see more metallicity, but when we are far from our center, we see less metallicity. Abundances for CP1 stars. if you remember, I told you that for CP1 stars, we have no magnetic field. As you see in here, more elements are higher. Is lower than the 0. But for CP2 stars up to CP4 and CP4 stars that both have magnetic field, we see that the abundances are more higher than the 0. So we can say for CP1, CP2 and CP4 stars that have magnetic field, they are higher than 0. But for CP1 and CP3 stars that have no magnetic field, they are mostly lower than 0. The abundances are lower than 0. So magnetic field is so important for abundance, metallicity. Here also you see that for CP3 stars that have no magnetic field, they are also again lower than 0 for abundances. We have some classification. Parameters to estimate are spectrum type, temperature, luminosity, V sinus I for rotation, and metallicity. Maybe you ask how we can measure that. With line strength, with line ratios, and with equivalent widths. For example, for line ratios, for example, we have 2 iron lines or more. If it is better that we compare and we have ratio of them, not measure them, each one of them individually. No, the ratio is more precise than measuring them individually. And why? Because it is more tested and it is very efficient. We have different classification for stars. And the first one is O. We call them O, B, A, F, G, K, M. And maybe sometimes we call R and N also. And we have some official subclasses. For example, for our sun, we have G2. Our sun is G2 star. For example, when we have something, for example, HA0KA5MA3, we see that this means that the hydrogen line have the characteristics as in a A0 star, calcium, hydrogen, and potassium. K has A5 characteristic, and the metallic line have A3 in classification. Here you see that for each classification, we can say that they have different, for each element or abundance, we have different classification. For example, in this, you see that for a spectral type, for example, hydrogen is here for classification A0. Or iron, Fe2 or Fe1, they have different classification, G0, K0, and M0. Here is what we do for classification spectroscopy. For example, polymer lines. If it is visible, if it is yes, we have calcium, hydrogen, and potassium. If it is visible, yes, we go to next step. If it is no, we go to this step. And at least we have different reasons. And this is what we have for manual measurement and computer measurement. And you see that there is a very good compatibility between manual measurements and computer measurements. Thank you for your attention. See you next session.